Very good evening to all of you. Am I audible? Just confirm. Yes, am I audible to everyone? Hello, Priyanka, others. Am I audible? Okay. I okay. So I welcome you all in this class. You all know it is going to conduct state engineering services examination, that is assistant engineer in electrical branch. So here is it is your syllabus. The very first subject is basics of electrical engineering. There are so many subjects like electrical machines, power systems, network, analog electronics, digital electronics, measurement, control system, electromagnetic fields, and basic electrical engineering. So we are starting our course from this very basic course, which is basic electrical engineering. Basic electrical engineering. So in this course, yes, yes. So in this course, we will learn about the basics of electrical engineering. Like we will start from charge, then we will go to voltage, then we will go to current, then we will go to the properties of the material like R, L, C. Okay, so we will discuss all these quantities, all these terms, all these parameters in detail. So this is our syllabus, and we are bound to discuss within the boundaries of syllabus only. So this is the syllabus of basic electrical engineering. The very first topic is DC circuit, then magnetic circuit, then single phase AC circuit, then three phase AC circuits. And here are some prerequisites. Prerequisites are before going to discuss all these, you should know what are the charge, what is current, what is voltage, what is resistance, what is inductance, what is capacitance, what is AC and DC supply, what is single phase and three phase supply system, what is Ohm's law, and what is KVL and KCL. So these are the prerequisites. I will discuss all these things in detail. Let us start from the very beginning, that is charge. What is charge? What is charge? Okay. Let me check. Someone want to say something? No. Okay. No, sir. So what is charge? So before going to start, let me show you this notes. I have prepared this file exclusively for you as per your syllabus. These are the prerequisites. You can say these are the current voltage and all. I have prepared it from last 5 to 6 days, and this file contains all the contents of basic electrical engineering. Here you will see what is inductance, capacitance, how they behave, what are the symbol of resistance, what are the properties of resistance, what are the linear elements, non-linear elements, unilateral element, bilateral element, current source, voltage source. So I have designed these notes according to the syllabus, and this is very concise in nature. Unilateral network, bilateral network. So there are nearly 50 pages for this particular subject, basic electrical engineering, and we are discussing our first topic, that are the charge. So charge is the fundamental property. Charge is the fundamental property of subatomic particle. Any atom contains some nucleus and some orbit. So positive charges lies in the nucleus, which are known as proton, and negatively charged particles are circulating in its orbit. And this structure known as the atomic structure of any material. So these are the negatively charged, and this is the positively charged. So what is electron? Electron is the fundamental. Electron is the fundamental property. Electron is the fundamental property of subatomic particle that give rise to the phenomena of experiencing force in the presence of electric or magnetic field. Means this is a material whose atomic structure is like this, and we are applying some electric force across it. we are applying some electric force across it, so it will behave accordingly. It will behave accordingly. If it is a conducting material, then current will start flowing. If it is a inductive material, insulating material, then it will stop the flow of electricity through it. So what is this current? What is happening before this current? That is nothing but charge. So what are the charges? Charges lies in the orbital region of the atomic structure, and these are the free in nature. These are the negatively charged, which are the electrons, and they feel some experience. They feel some experience means this is the charge, this is the charge, and if it is if some electric field is appears across the charge, it will experience some force. This charge will experience some force, and by virtue of that force, it will start rotate, it will start changing its position, or we can say change of charges, dq by dt. Dq by dt happens inside the conductor. So according to this dq by dt, and the current will start flowing through the conductor. So these are the very theoretical definition, and again, this definition will not come into your examination. These are the prerequisites only, because we have to discuss current, we have to focus on current. So before knowing what is current, we should know what is charge. So what is charge? Charge is the very fundamental property of subatomic particle that gives rise to the phenomena of experiencing force in the presence of electric and magnetic field. That's it. This is the sufficient definition of electric charge. And now, what is the properties of charge? So they are the negatively charged, and its fundamental magnitude of the charge is minus 1.6 into 10 to the power minus 19, and its unit is coulomb. So all these important points are written here. Like electric charges comes in two main types: positive and negatively charged. So positive charge means what? Positive charge are associated with proton. Positive charge associated with proton, and they lies in the nucleus of the atom. They lies in the nucleus of the atom. They are represented by symbol plus. These are the protons, positively charged. On the other hand, negative charge is linked to electrons. Negatively charged means what? Electrons, and electrons are which orbit the atom nucleus and are denoted by symbol minus. So charges are negatively charged and denoted by the symbol minus, and it can be represented by q, and q is equal to it. And electric charge comes in discrete invisible units called elementary charges, and the smallest unit of electric charge is what? That is the minus 1.6 into 10 to the power minus 19 coulomb. So this is all about charge. Now nothing else. Charge is over. So what is charge? Charge is equal to I into T. Broadly, we can say Q is equal to I into T. It is written in this page number 1. Q is equal to I into T. Okay, this is written here. Q is, and I will provide this PDF note just after this lecture. So don't worry. Just listen what I am saying. These are the prerequisites. Okay. Now come to second point. What is current? Now from here our journey starts. So I assume all of you are the BTech graduates, and it is very silly to teach you charge and current, but these are the requirement of the course. We cannot skip any parts. We have to discuss accordingly. That's why while preparing the notes, I was thinking that a student will think that why sir is teaching the charge and current, we know all these things, but these are the fundamental differences. Sometimes it is very helpful to know the fundamental concepts of current, voltage, charge, power, energy. These are the very helpful. Okay, so what is current? If someone asks you what is current, what you will say? Sir, current is nothing but flow of charge. What is current? Current is flow of charges. When current will establish in any conductor, let's say this is a conductor, when current will establish through this conductor, when current will start flowing through this conductor? After the application of any electric field. And what is happening if we apply any electric field? What is happening if we apply any electric field? So one second. So if we apply any electric field, one second. Okay, so sorry for the disturbance. Yes, yes, this one. So what is happening when you apply any potential or electric field across this material? What this atomic, this is the small atom contains some charges, minus charges. They will experience some force, and by virtue of that force, they will start moving. They will start moving. So this is the symbol of a battery, and this is the positive terminal of the battery. Yes. So now this plus terminal will exert some force, and the minus means the charges will come close to this plus point, and from this minus terminal, these electrons will experience some force, and they will move away from this minus point, this minus connection. So electrons are flowing from minus to plus, electrons are flowing from minus to plus, and conventional current is flowing in opposite direction of the flow of electrons. This is the direction of current, and this is the flow of electrons. So electrons are flowing from minus to plus, and current is flowing from plus to minus. So what is current? What is current? Current is the rate of change of charge. Rate of change of charge. Rate of change of charge is nothing but current. It is denoted by I. Its unit is ampere. Its unit is ampere. So this is a very very precise definition of current. It is written here also. Now what is voltage? What is voltage? This is very important. What is voltage? And sometimes it is also known as EMF, electromotive force. Electromotive force. So electromotive force means force required to move a charge. Force required to move a charge is known as what? Is known as voltage. So it is written, the force that acts on electrons, the force that acts on electrons to make them move, in certain direction, is known as electromotive force. Means this is the V, and it will offer some force to the Q to make it rotate, to make it transport from one place to another place. So in this way the work can be done, and the charge required to perform the work, the other definition of voltage is equal to dw by dq, means the work done per unit charge. Done Work done per unit charge. So this is nothing but your voltage, and it is otherwise known as EMF. EMF means what? Electromotive force, a force required to move the charge for the work done. Force required to move the charge for work done. This is the EMF, and its analogy. One analogy for EMF is also, these are the two water tanks. These are the two water tanks located on the top roof. Okay, and let's say they are connected. They are connected with a small pipe like this. Okay, and let's say the pressure inside this tank is P1, and the pressure inside this tank is P2, and they are connected through this pipe. And if I am saying P1 is less than P2, then water will start flowing from, P2 to P1 until P2 is equal to P1, until P2 is equal to P1. So what this P2 and P1 is doing, these are the pressure, and pressure decides the flow of water from high pressure, from high P to low P. The water will flow from high P to low P. Similarly, if two batteries are connected in same direction. Let's say this is the 10-volt battery, this is the 5-volt battery, this is the plus terminal, this is the minus terminal, this is the plus terminal, this is the minus terminal, and they are connected through a resistance. Let's say this is the resistance, let's say a 5 ohm of resistances. They are connected through a 5 ohm resistance. Now what will happen? They will try to start flowing the current through them. Batteries will try to start the flow of current. This battery will force the charges in this direction, and this battery will try to force the charge in this direction. But who will win this race? I think this 10 volt is higher than this 5 volt. So the ultimate, so the final direction of current in this circuit will be like this, because this is aligned across the direction of this 10 volt battery, because 10 volt battery, the magnitude of 10 volt battery is higher than the 5 volt battery. So we will discuss this type of problems later in this course. So this is about the EMF. EMF means voltage, and what are the sources of voltage? So voltage can be obtained from the battery. Batteries are the sources of voltage. Generators are the sources of voltage. So in this particular BEEE, in the later sections, we will discuss the voltage, type of voltage sources, their properties in detail also. So here only we are discussing only the what is the definition of voltage. So now how you will define the voltage? There are two definitions. Number one, sir, voltage is the force required to move a charge from one point to another point. Number two, sir, voltage is defined as the work done to moving a charge from one point to another point. Let's say this is a charge Q, this is a charge Q1, and this is the charge Q2. Let's say this is the charge Q1, and this is not charge Q2. This is a location. This is location B, and this is location A. Charge Q1 is located at location B, and this is some another location, that is location B. If you are moving this Q1 particle from A to B, so definitely you are doing some work. You are doing some work, and for that work, whatever the force you are using, that is decided by the whatever the voltage you are having. So how you will define voltage here? Voltage is the voltage is the force required to move a charge from one point to another point. Or otherwise you can define, sir, voltage is equal to work done per unit charge. Work per unit charge. So what is the unit of volt here? It is the, what is the unit of work? That is the joule. What is the unit of charge? That is the coulomb. So another unit of volt is joule per coulomb, or regular unit of voltage is what? It is volt. Okay, so just let me confirm. Am I audible or any problem? Are you listening my voice? Just drop a message in the chat box. Okay. Thank you. I got your response. Yeah. So this is voltage. This is voltage. Now the next is, we have covered the current. We have covered the voltage. Now what is the resistance? This is again very important. What is resistance? So let us see what is resistance. So let's say yes. So resistance, R, resistance. In general language, resistance means what? It is a property. It is a property of a material. This is the property. Yeah, this is the property of a material by virtue of which it opposes the flow of current. It opposes the flow of current through this material. It opposes the flow of current through the material itself. That property is known as resistance. This is a resistance, means it is opposing the flow of current through it. So we were starting our discussion from charge, then we have moved to current, then we have discussed the voltage, now we are discussing the resistance. So here we was discussing from very atomic level. Then here we were discussing about the dq by dt. Here what was the voltage? It is the dw by dq. Now the resistance means the overall property of the material, not the atomic structure. Overall property of the material by virtue of which it opposes the flow of current. It opposes the flow of current. So this is resistance. The same is written here. You can read it. These are the very simple. You all are the engineers. You know what is resistance. So electrically, resistance is defined as the property of the material by virtue of which it opposes the flow of current or rate of change rate of change of charge through it. So rate of change of charge is nothing but current. Rate of change of charge is nothing but current. So either you can say it opposes the flow of current, or you can say it opposes the rate of change of charges. Okay. So again, one more thing, resistance of any material depends on its physical property. Resistance of any material depends on its physical property. That's why the formula of resistance is what? Resistance is equal to rho L upon A. So what is L? L is the length. L is the length. It is written here. L is the length of the material. What is the A? A is the cross sectional area. A is the cross sectional area of the material in meter square. Length in meter. This is meter square, and this is ohm per meter. This is the resistivity. I have inserted a table of resistivity of important electrical materials in the next page. So what is resistance? Resistance is a property by virtue of which it opposes the flow of current. If it opposes the flow of current through this material, and its symbol is like this. Its symbol is like this, and its unit is ohm. Its unit is ohm, and its job is to oppose the flow of current. If a material allows the easy flow of current through it, that material will comes under the category of conductive material, because it allows the flow of current. Its resistance is very low. If any material does not allow the flow of current through it at all, that material will lies under the category of insulator. That material will lie under the category of insulator. Examples, what are the examples of insulator? Wood, porcelain. Okay, and what is the examples of conductor? So we can see in our homes, inside the wire, there are the copper wires. We can see sometimes silver wires, and gold is also the good conductor of electricity. So in this table you will find several materials with their resistivity. For the sake of your knowledge only, so this is the silver, and the resistivity of silver is 1.59 into 10 to the power minus 8 ohm meter. Very small, means this is the very good conductor. This is very good conductor. Now the next material is what? Copper. The resistivity of the copper is 1.72 into 10 to the power minus 8. Resistivity of gold is 2.44 into 10 to the power minus 8. Means resistivity of copper is less than resistivity of gold. Means this one is good. This one is good conducting material. This one is good conducting means which allows the flow of current easily. It is the conducting material. Okay. And similarly, aluminium, tungsten, iron, platinum, steel. Now come here, mercury. What is the resistivity of mercury? It is 96. And what is the resistivity of copper? 1.72 into 10 to the power minus 8. It is 96 into 10 to the power minus 8. Huge difference. Means this is a good conductor as compared to this. Now, moving forward, we have come to the insulator, semiconductors. Semiconductor means whose property lies between the conducting materials, whose property lies between conducting materials and insulating materials. Insulating means total opposition. Conducting means total support, and semiconductor means partial conduction and partial blockage or insulation. So partial conduction and partial insulation. So what are the examples? What are the examples of semiconductors? Carbon, germanium, silicon. So silicon is very popular semiconducting material. Germanium is very popular semiconducting material, and their resistivity lies under the range of 3.5 to 60 into 10 to the power 5 ohm meter. And for germanium, it is 1 to 600 into 10 to the power minus 3 ohm per meter. So these are the semiconducting materials. Now the third one is insulating material. So you are very familiar with this term, wood. What is the resistance of wood? Very high, 10 to the power 8 to 10 to the power 11. Teflon, sulfur, rubber, quartz, mica, glass, amber. So all these are the examples of insulating materials. They are used where electricity is not desired to flow. These are the insulating materials. and resistance depends on the physical property of the material, means R is equal to rho L upon A. If I am asking this is a material, this is a material, and some current is flowing through it I, and its resistance is R, and its length is L, and its cross sectional area is A. Its cross sectional, let's say this area is what? A. If I stretch this wire, and now its length increases from L to L1, what will happen to its resistance? What will happen to its resistance? The resistance earlier, which was R, now it is R1 corresponding to L1. So what is the relation between R and R1? Which one is high and which one is low? Anyone can want to say something? Open your mic and tell me, among R and R1, which one will be higher? Okay, so R1 is directly proportional to L, means resistance is directly proportional to the length. If length is increased, resistance will also be increased. That's why the resistance will increase if you are stretching any conducting materials. So same thing happens with uh, area. Same thing happens with area. So resistance is inversely proportional with the area of the material, cross sectional area of the material. For this area, for this cross sectional area, resistance is R1. For this cross sectional area, resistance is R2. And now tell me, amongst R1 and R2, which one will higher? So R2 is high, so area of R2 is high, so the resistance of R2 is low. So this relation will be there. For increment in area, this will happen. For increment in length, this will happen. Okay. One small question is written here. What happens to the resistance of a pure metal with an increase in temperature? With an increase in temperature, what will happen? Just tell me what will happen. Let's say this is the material. This is the material whose resistance is R. Now I apply some fire here. I apply some fire here to increase its temperature. To increase its temperature. So its electrons will start accumulating, get collide very fast, and participate uh, in very faster manner at the earliest. Now what will happen? So as the temperature increases, the resistance of pure metals increase. The reason behind this is the increase in the number of electrons, increase in the number of electrons in the conduction band, which reduces the mobility, thereby increasing the resistance, so electrons, the mobilization of electrons will increase, so their amount in the conduction band, will increase, and correspondingly the resistance will increase, and similarly, what will happen to the resistance of insulators when an increase in temperature? So as the temperature increases, the resistance of insulator decreases. The reason behind this is the electron movement from the conduction band to the valence band increases as the energy gap between these two bands is large. Therefore, conductance increases and resistance decreases. So opposite phenomena happening for conducting material and insulating material while increasing the temperature near the material. So for conducting material, the resistance increases, and for insulating material, the resistance decreases. Okay. Now, I have seen in your question paper, last year question paper, and I have found these type of questions frequently. One resistance is there and having some color codes. Let's say this code, this is red, and this is, let's say, black, and this is, let's say, green, and this is, let's say, gold. This is, let's say, or you can say brown. So now tell me the value of resistance. So this will come under the color coding of resistances. So the next heading is resistance color coding, and you might have seen these type of resistances in your colleges. These resistances are known as carbon resistances. Which type of resistances? Carbon resistances. They offer very high resistance, kilo ohm to mega ohm, but their power handling capacity is very low. And you have seen this type of resistance also in your machine laboratory, I think. Resistance. Okay, so you might have seen these type of resistances also in your machines or okay, this is the joystick. So this resistance offer only, let's say, 32 ohm, and this resistance may offer 32 kilo ohm, but their size is very lesser in area and size and dimension, and its size as well as its weight and as well as power handling its power handling capacity is high. So these type of resistances are known as high power resistances. They are using for high voltage applications, and these are the low power resistances, and they are used up to DC circuit, 12 volt, 10 volt, 50 volt, and for very less amount of power. Okay, so now come to the point. We will discuss the color coding of resistances. Now we will discuss the color coding of resistances, and before discussing that, let me clear one thing. You might have seen this type of resistance in your laboratory, BEEE laboratory. You can see there are one, two, three, four color bands are there, and three are placed nearby, and fourth one is little bit far away from these three. Now, how to read the value of this resistance? The formula for reading the value of this resistance. Let's say I am categorizing this as A, I am categorizing this as B, I am categorizing this as C, and I am categorizing this band as D. So the resistance offered will be, this is the formula of resistance, that is A B into 10 to the power C plus minus D. This is the formula for measuring the resistance through the color codes. Now what you will place in place of what you will put in place of A, B, C and D, so that we will find from this table, so let's you can see for black color, what digit you will use? 0. And what multiplier you will use? 1. 1 means what? 10 to the power 0. Here 10 means what? 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4, 10 to the power 5. And now come to the question, come to this question in the previous page. What type of colors are there? I think it is red, black and gold. Red, black and gold. Red, black and gold. So let me write. First color was red, then red, then black, then gold. So this is A, this is B, this is C, this is D, and total resistance will be A, B into 10 to the power C plus minus D. Now what is A? So where is red? It is red. This is red. So what is its digit? 2. So put here 2. Now B again. B is also red. So 2 2 into 10 to the power C. In place of C, what is there? Black. Black means what? 10 to the power 0 plus minus. What is there? Gold. So you can see gold. What is the tolerance? This is tolerance. This is tolerance is written here. So tolerance for gold is what? 5%. So you can write the 5% plus minus 5%. Plus minus 5%. So final value will be 22 into 10 to the power 0 is nothing but 1 plus minus 5%. The final value will be 22 plus minus 5%. So this is way to read. We have I have covered some questions in the next page. We will discuss those questions also. Now read this. Determine the resistance of the resistor with a given color sequence. Now this is the question. Red, green, red, gold. Will you try to solve this question? Red, green, red, and gold. So these are the these questions come very frequently in SPSC examinations. So this is what first color is red, then green, then red, then gold. So red, for this red, what is written here? Digit 2. For green, what is written? 5. 2, 5 into 10. 10 to the power 2. This is what for red. It is what 10 to the power 2. Plus minus for gold. What is the tolerance? This is the tolerance. This is the tolerance. For gold, it is what? It is plus minus 5%. It is plus minus 5%. So what do you understand by this tolerance? So this tolerance means this is, let's say, 2500 plus minus 5%. So you can otherwise write it as 25 kilo ohm plus minus 5%. Means plus minus 5% is what? This is the variance error. Matlab, this resistance can vary from 2.5 kilo ohm, and upper limit is plus 5% and lower limit is minus 5%. It can lie in between these two limits. So this is the meaning of this tolerance. So for gold, tolerance is 5%, and for silver, if silver line is there, tolerance is 10%. For silver line, the tolerance is 10%. Again, the next question is again very important. What color bands would a resistor of resistance value 1000 ohm with a tolerance level of 5% have? Now, this is the question in the reverse manner. Here, the value of resistance and tolerance is given. Now, you have to find out the color coding. So, 1000 ohm plus minus 5%. So, you can write here 1000 ohm plus minus 5%. This is the next question. What is there? 1000 ohm plus minus 5%. Now start watching this table. 1000 means what? 0 1, no 1 1 into yes, write the formula first. A b into 10 to the power c plus minus d. So in place of d, your gold is there. So here it is gold, and for a it is, you can take brown. You can take brown, then you can take black, brown, then black, then so brown and black means, brown means what? 1, black means what? 0. Now 1 0 is there. How many zeros are required? 2 more zeros means what? Here red. So brown, black, red is the correct combination. What is the correct combination? Brown, then black, then red, then gold. Now check it. For brown, what is written here? For brown, it is 1. For brown, it is 1. For black, it is 0. So you can write 1 0 into 10 to the power red. For red, the multiplier is 2. 10 to the power 2. And for gold, the tolerance is plus minus 5%. To 10 to the power 2, and this 10 means what? 1000 ohm plus minus 5%. So this is the correct combination. This is the correct. And the short trick for remembering this color coding is B.B. Roy, Great Britain, very good wife. We in our college days we remember it like this. So black, B.B. Roy, black, brown, red, orange, yellow, green, blue, violet, very gray, white, and the tolerances are gold and silver. For gold 5%, and for silver it is 10%. And you can, yes. and you can see here 0 1 2 3 4 5 6 7. Yes. 0 1 2 3 4 5 6 7 8 9. Okay, so these are the digits, these are the multipliers. Yes, we will discuss the one second. Yes, now I am audible. Yes. Sorry for that. Sorry for that. So I think I have discussed it. This is the color coding of resistance. I have discussed it in detail, and I will give you some problems for depends on this table and try to solve those problems. In the next class, we will discuss those problems. This is the B, Roy, Great Britain, very good wife, gold and silver. 0 1 2 3 4 6 7 8 9 10. 5%, 10%. Here again multiplier 0 1 2 3 4 5 6 7 8 up to 7. These are the very higher multipliers. Not, you will not see these multipliers in the real registers. Okay, so I think my voice was turned off, so let me discuss the inductance once again. What is the inductance? So inductance is the property of the material by virtue of which it opposes any change either in magnitude or in direction of the current flowing through it. Means what was happening earlier, okay, what was happening earlier, this was the material, and we were giving it some current. Now what this material will do, it will oppose the flow of current, simple, and that property is known as resistance. Now the advanced property of this material, it will not resist, it will not provide the, I mean, resistance is the property by virtue of which it opposes the flow of current. Now come to the advanced property, that is inductance. By virtue of this property, it will oppose the change in magnitude or the change in direction of current, not the flow of current, inductance will not oppose the flow of current, but it will oppose the magnitude and direction. If there is change in magnitude and direction of current which is being flow through it, so it will oppose, simple, it will oppose. And for AC supply, both magnitude as well as direction are changing at regular intervals, so inductance property come into the picture for AC supply. This I was discussing when my mic was turned off, and sorry for that. So this is very simple. Now another property of inductance with respect to magnetic circuit, it is the flux linkage per unit current. This is the flux linkage per unit current. We will realize this property when we will be discussing the magnetic circuits. Okay. Now the next property of the material is what? Capacitance. The next property of the material is what? Capacitance. Now capacitance, again, as the inductance property is opposing the change in magnitude and direction of the current, in the same way the capacitance property will oppose the change in magnitude or the direction of voltage. Change in magnitude or the direction of voltage, not the direction of or magnitude of current. This is related to voltage. That's why you can define the C. It is represented by C. Its unit is farad. And it opposes the change of voltage. Dv by dt. It opposes the change of voltage. This is the definition of C as per its property. Now again, the C is a capacitor, is a device. You can see this type of devices in the market. These are the capacitors. Two terminals are there, and some dielectric are placed inside this material. Based on that dielectric and based on the we can say structure of this device, we can call it as spherical capacitor, cylindrical capacitor, parallel plate capacitors and all. Okay, so based on its shape we can call it like this. And what is there inside the capacitor? There are some dielectric material. What are the dielectric materials? Dielectric materials are those materials which stores electrical charge, and these are the parallel plates, and we are supplying the electricity on these two terminals, plus and minus. These are the parallel plates and this is the charge. Now what is capacitance? Again, what is capacitance? To read this definition very carefully, first of all, as we have discussed in case of inductance, we can define, sir, capacitance is the property of the material by virtue of which it opposes any change either in magnitude or in direction of applied voltage across it. Means this is the voltage, if its magnitude or direction is changing, then capacitance will come into the picture. If this type of voltage you are applying, this is what DC voltage, this is what AC voltage. So for DC voltage, what will be the capacitance? So what will be the capacitance? It will be infinite. Why it will be infinite? We will discuss when we will be deriving the derivation of the capacitive reactance. Then I will discuss this thing. Okay. Now what is capacitance? So capacitance is the ability of system to store electric charge. Capacitance is the ability of the system. Capacitance is the ability of the system to store electric charge. The ratio of change in electric charge in a system to the corresponding change in its electrical potential. Means we can say the capacitance is the charge per unit voltage, change in charge per unit voltage. Means it is the capacity to store the charge, and it is the ratio of electric charge in the system to the corresponding change in electric potential. Means to store that much amount of electric charge, how much potential change is required. That is capacitance. Another definition based on physical property, its unit is farad. It stores energy in the form of electrostatic field. Capacitors and batteries both store energy, while batteries release energy gradually and capacitors discharge it quickly. So what is the difference between a battery and a capacitor? Battery can release the energy gradually and capacitor can discharge the energy quickly. So based on the physical parameters of the capacitor, the capacitance also be defined as C is equal to epsilon A upon D. Now what is this epsilon, what is this A, what is this D? This is the physical definition. This is the physical definition of capacitance. So there you have 2 to 3 formulas for capacitance. Number one is written here. Number 2 is I dV by dt. What this formula is saying? This formula is saying this capacitance is inversely proportional to this rate of change of voltage. Capacitance is opposing the rate of change of voltage. This is the definition according to property number 1. This is the formula according to its physical property. And again, C is equal to what? Q upon V. I mean, this stored charge Q, and for storing this charge, this much amount of change in voltage required. Means V2 minus V1, old voltage minus new voltage, change in voltage is required to store this much amount of charge. So there are 3 formulas for capacitance. You can use them accordingly. Now come here. So this is the capacitor, and this is what? This is the dielectric material, and these are the what? These are the plates. And this type of capacitor is known as parallel plate capacitors. Now this plus terminal is connected to this one, this minus terminal is connected to this one. After applying electric field, the plus charges come to this plate, and the negative charges come nearby this plate, and here the store of energy takes place in this dielectric material. Now what is the mu, what is this, sorry, this epsilon? This epsilon is the permittivity of the dielectric material. This epsilon is the permittivity of the dielectric material. Its unit is farad per meter. So dielectric material, you can use ceramic type capacitors, mica type capacitor, glass capacitors, paper capacitors. Okay, so this is about the capacitor. Now come to the next point, that is, yes. So till now, what we have covered, we have started our journey from charge. Then we have discussed current. Then we have discussed voltage. Then we have discussed resistance. Then we have discussed inductance. Then capacitance. Now and little bit AC and little bit DC. We will discuss AC and DC in detail also, but little bit we have discussed. Means what? AC is alternating in nature like this. The pattern of AC waveform with respect to time, either voltage or current, is like this, and the pattern of DC waveform with respect to time is this. It is constant. This is constant at any point of time. Its value is, let's say, 10 volt or 20 volt or x volt. Okay, now the come to the next point, that is the Ohm's law. Again, we have not started our syllabus yet. We are only discussing the prerequisites. Okay, so Ohm's law is very common and very useful throughout the BEEE and network analysis. We will use Ohm's law directly or indirectly. It is saying very simple. Now current and voltage are there. Now what is the relation between these two? Now what is the relation between these two? If this is a material and you have applied some voltage across this material, plus and minus, let's say this is a voltage, so definitely the current will start flowing. Now what is the relation between this current and voltage? This relation is defined from Ohm's law. Relation is defined from Ohm's law. What Ohm's law is saying? Ohm's law is saying that the current flowing through the material is proportional to the applied voltage. The current flowing through the material, this is the voltage, this is the current. As far as you are increasing the voltage, your current will increase. As far as you are increasing the voltage, your current will increase in a linear fashion. So you can say the slope, you can see the slope is constant here. This is the slope is constant, and this slope is nothing but what? R. And R is again what? Resistance of the material, and it is otherwise known as what? Proportionality constant. So you can see Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference applied across its end, provided all physical conditions and temperature remains constant. This statement is this line is very important. I and V are proportional, it's okay, but up to certain instant, up to its temperature, it's constant at room temperature. It will happen at room temperature. If you are increasing the temperature, then your resistance, which is the which depends on the physical property of the material, that is rho L upon A, and we have discussed it again in the previous discussion, that resistance depends on the temperature also. If you are increasing the temperature, then your resistance will change and Ohm's law will fail. That's why this line is very important, provided all physical conditions and temperature remains constant. So this is very simple. I is proportional to V, I is equal to V by R, and this R is proportionality constant. It is nothing but resistance of the material. Now again, the next law of basic electrical engineering, very useful law, that is what? Kirchhoff's voltage law. Kirchhoff's voltage law. Now you can see here, this is what? This is a battery, this is a battery, this is a resistance, this is also a resistance, and this is also a resistance. You can see all these resistances are connected in series with this 45 volt of battery, and you can see 1 2 3 4 4 points are there. 1 2 3 4 are forming a closed loop. 1 2 3 4 are forming a closed loop. Means we can say this is a closed circuit. This is a closed electrical circuit. This is a closed electrical circuit. Now what is KVL? KVL is saying inside a closed loop, the the algebraic sum of all the voltages is equal to 0. Algebraic sum of all the voltages is equal to 0. Now see here, uh, this is a 45 volt battery. This is a 45 volt battery, no problem. This is a 5 kilo ohm resistance, 10 kilo ohm resistance, and 7.5 kilo ohm resistance. Definitely, if you are connecting some resistances with a battery, so the current will start flowing because a closed loop is forming. When current will flow? Whenever there is a source and there are the loads. So this is a 45 volt battery. This is plus, this is minus, and this is 5 kilo ohm. This is 10 kilo ohm, and this is 7.5 kilo ohm. Now proof the KVL. What KVL is saying? KVL is saying the voltage algebraic sum of voltages are 0. Now you will ask, sir, what is meant by algebraic sum? Why you are repeating it again and again? And what is written here? What is this sign? This is the sum. This is the sum of all the voltages. Sum of all the voltages in the loop. Now tell me how many voltages are there? So this is the voltage of battery, that is 45 volt. Here this is the resistance, and according to Ohm's law, V is equal to what? I into R. So the voltage drop for this resistance, let's say this is V1. The voltage drop for this resistance, let's say it is V2, and the voltage drop for this resistance, let's say it is V3. So what KVL is saying? KVL is saying that this 45 should be equal to V1 plus V2 plus V3. Means whatever the voltage you are supplying to this network, all the voltage is dissipated or drops in these three resistors. If if there is a balance, means KVL is satisfied. If there is not a balance, means they are not equal to each other, means KVL is not satisfied. Otherwise you can say, sir, 45 minus V1 minus V2 minus V3 is equal to 0, or otherwise you can say sum of all the voltages is equal to 0. So algebraic means what? Algebraic means if someone is delivering, take it with minus sign. If someone is receiving, take it with negative sign. If someone is delivering something, then give this plus sign to that element. If someone is receiving something, put the negative sign to that element. So 45 minus V1 minus V2 minus V3 is equal to 0. And you can check it also. So first of all, how to calculate V1 V2 V3? For calculating V1 V2 V3, we need to calculate this current I, and for calculating this current I, we need to calculate total voltage. We know I is equal to, V upon R, and this R is what? Total resistance, and total resistance is what? 10 plus 5 plus 7.5. So you can calculate it. 10 plus 5 plus 7.5, and it is nothing but 22.5. So this is 22.5 kilo ohm. 22.5 inverse into 45, that is what? That is 2 milliampere. So this I is what? 2 milliampere. Now put this 2 milliampere here. So 45 is equal to, what is V1? V1 means what? 2 into 10 to the power minus 3 into what? 5 into 10 to the power 3. Kilo means plus 3, and milli means minus 3, plus 10 into 10 to the power minus 3 into 5 into 10 to the power plus 3. This is the voltage drop in 10 kilo ohm resistor. Similarly, in continuation, plus 7.5 into 10 to the power, 10 to the power what? Kilo means what? 3 into I 5. I was 2 milliampere. It is plus 3, and here it is 2, it is minus 3. It is 2 into 10 to the power minus 3. So you will find a balance. Like plus 3 minus 3 plus 3 minus 3 plus 3 minus 3 cancel to each other. 5 into 2 plus 10 into 2 plus 7.5 into 2 is nothing but 45. You may check this. Okay, so here kvl is satisfied, we can say. Means algebraic sum means what? You need to take very I mean, this is very important to put this sign. I mean, where to put plus, where to put minus. If someone is delivering, if someone is delivering something, so assign the plus sign. If someone is receiving something, assign it with minus sign for receiving. So you can see this 45 volt is delivering, this 45 is volt is delivering the current, and this 5 kilo ohm is accepting the current. So the direction of voltage drops, plus to minus, plus to minus, minus to plus. So I will discuss this sign in detail when we will be solving the questions of mesh analysis. Okay, now come to the next point, that is KCL, Kirchhoff's current law. This is again very important. KCL, what is KCL? So KCL means what? KCL, let's say this is a node and some current is coming here. Some current is coming here. Let's say this current is I1, and some another current is coming here. Let's say this current is I2, and some current is going from here. Let's say this current is I3, and some another current is going from here. Let's say this current is I4. Now what is happening at this node? What is happening at this node? What you will write? Sum of all the incoming currents, sum of all the incoming current is equal to sum of all the outgoing currents, sum of all the outgoing current, and this is nothing but KCL. This is nothing but KCL. So what KCL is saying? KCL is saying that the algebraic sum of all the currents at any point, at any node, at any node A is equal to what? 0. If I am giving you a question, very simple question, let's say ki find the current, like 2 ampere, 3 ampere, it is 3, it is 4 ampere, and it is x ampere. What will be the value of x ampere? So simple, you can solve this problem by KCL. Sum of all the incoming current, 2 plus x is equal to 2 plus x plus 3 also. 3 is also incoming. Its direction is, this is incoming current, this is incoming current, this is incoming current. And this 4 ampere is what? It is outgoing current. So what will be the value of x? X will be 4 minus 3 minus 2. That is what? Minus 5 means minus 1 ampere. The value of x will be minus 1 ampere. So this is KCL. The same thing is written here. The algebraic sum of all the currents entering and exiting a node must be equal to 0. Algebraic means incoming current will assign with positive sign and the outgoing currents will assign with negative sign. And this law is used to describe how a charge enters and leaves a wire junction, point or node on a wire. Now you can see in this figure also. Let's say this is I total. This I total will be IR1 plus IR2 plus IR3, because at this point what is happening? This is incoming current and this is outgoing current. This is outgoing current. What equation you will write? You will write IR1. Sorry, I total will be IR1 plus IR2 plus IR3. Now IR2 plus IR3 will be, here you can see IR2 or IR3, no issue, they are same. Now IR3 is same, no problem, no problem. And here the I total comes back to the battery. Okay, so current and one more thing, until the circuit divide into the another branch. Let's say this is a branch, this is something like this type of structure. Okay, I am saying that some current I1 is flowing here, some current I2 is flowing here, some current I3 is flowing here. What I am trying to convey, the same I3 will flow through this resistor also, because this resistor, this one, and these resistors are connected in series. No further path is distributed from here. So the series, the current in series circuit is same. The current in series circuit is same. These are the fundamentals, I think you know. So this is the KCL, KVL, and again these are this table, consider the symbols. So this is the resistance, this is the symbol of resistance, this is the looks, actual look. These are the inductance, these are the symbol of inductance, this is the actual look of inductance. Now this is the capacitor, this is the capacitor. These are the like spherical capacitor, cylindrical capacitor, parallel plate capacitors. Okay, again diodes, these are the electron, I mean non-linear devices. We will discuss them in detail. Why we will be discussing the electronic circuits, transistors, analog electronics, non-linear element. Okay, and from here onwards, now from this point your syllabus starts. This is the very first point of your syllabus: linear and non-linear elements. So we will be discussing from here, from the next class, and the